All right, so today we are going to be looking at lesson 11.4. We're going to be looking at our angle side triangle congruence, and then we're actually going to look at a new triangle congruence. So Greg's boss is going to hand him a piece of graph paper, and it shows the plans for the trusses that we have been looking at building. He is wanting to find out if he can prove that triangle DBE is congruent to triangle FCE. So part A asks us to use the distance formula to find each length. So the first thing that we're going to do, using our distance formula, let's write what that is. The square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to try and do BD. So point B is at -2, 1, and point D is at -5, -2. So we'll plug those into our distance formula to find BD. So your two x's are -5 and -2. So -5 minus -2 squared. Your two y's are -2 and 1. So -2 minus 1 squared. We are going to end up with -5 plus 2, which is -3. And we'll again end up with another -3. -3 squared is a positive 9 because a negative times a negative is a positive. So 9 plus 9 is 18. So we have the square root of 18, which is 3 square roots of 2. So that's one side. For DE, you could use the distance formula, although it is unnecessary because it's a horizontal line. You can simply count to get 5 for that side. For BE, we already know what the side, the point of B is, so now we need to know the side down to E, which is at 0, -2, and that'll allow us to find that side length. So our x values are -2 and 0. 0 minus -2 squared, and then 1 minus -2 squared. Remember, you can switch the order. It doesn't matter which one comes first. You could do x2 minus x1 and y1 minus y2, or vice versa. So 0 plus 2 is 2. 1 plus 2 is 3. So then we have 2 squared, which is 4, and 9 is going to be 3 squared. So 4 plus 9 becomes 13, so we have the square root of 13. And then, using the distance formula, again for the other sides, you're going to end up with 3 square roots of 2, 5, and square root of 13. So you're going to do the same process there. I'm not going to work through all of them completely. I will tell you, C is the 0.21 and F is the 0.5, -2. But you should end up getting the same lengths. So part B asks, can Greg use this information to prove that the triangles are congruent? Yes. And it would be by side, side, side. Because we found 3 pairs of sides that were congruent. These were congruent, these were congruent, and these were congruent. So by side, 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 we know that they are congruent. Now we're going to look at number 2. A couple of lessons ago, we looked at side, 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 and angle, side, angle. And we also looked at angle, angle, side. So that was the one that we did not look at in the previous lesson. So we are going to look more specifically today at angle, angle, side. We want to mark in our triangles what angle, angle, side even represents. And it says, what is it, like, what is that? That would be if you have 2 angles and the non-included side of one triangle. So here are 2 angles, and then the side that is not in between those. So it could be this side or that one. You just got to pick one of them. So I'm going to put a mark on the one on the left. And then they have to be congruent to the corresponding two angles and non-included side of another triangle. So here are my two angles, and if I pick this angle over here on the right, left, I have to pick that same angle on the left there. So that would be an example. And since we have two angles and the non-included side on both of our triangles corresponding, the triangles have to be congruent. So the reason that we're going to be looking specifically at angle, angle, side today, it is different from the other three that we looked at in the previous lesson. Side, 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 angle, side, and angle, side, angle are all postulates, and they don't have to be proven. We accept a postulate to be true. Angle, angle, side is an actual theorem, and so we are going to end up proving it in just a few minutes. So how might the proof of angle, angle, side be different from the proofs that we looked at in the previous lesson? Well, we were dealing with a postulate. They don't have a formal proof. So that's why we didn't have any two-column proofs when we were looking at lesson 11.3. We had some general ideas, but there weren't any specific proofs for those lessons. So we are going to now look on the next page and actually prove angle, angle, side. So since we are proving angle, angle, side here, it is not going to show up anywhere in your proof. So nowhere in your proof should you have angle, angle, side. We are just proving it. So a couple of things to think about when you're working through these proofs. There are going to be multiple ways that you could prove this. They are just going to give you one, like this is just one way. So you may see it in a different way, but this is the one that the book chose for us to help finish, and so we're going to go with that. This proof isn't exactly the same as what we were doing yesterday with lesson 11.3, in the sense that this is a formal proof of a theorem, and what we were doing yesterday was more showing how they worked with our proof. You could almost think of it as a proof in quotation marks for what we did with 11.3. So when you look at this, yes, it is a long proof. There are 10 statements and reasons. And so one thing that might help you is just to go through and fill in your given information. Like go ahead and put in the reasons that are given. So we're given our triangles here. So statement number 1 is a given. So we can write given for reason number 1. It also tells us that these angles are congruent. And that is statement number 4. So we can write given in our reason number 4. And then we have another given with those MO is congruent to PR. And so statement number 9 is a given. So we have 3 different givens here. So sometimes that'll be helpful to go ahead and put your given in your reason column. Another thing that can be helpful is to actually mark the given information on the figures. So I have angle N and angle Q are congruent. Angle O and angle R are congruent. And I know MO and PR are congruent. So if you look, these triangles are congruent. We see that by angle, angle, side. But we are trying to prove angle, angle, side. So that's why we're not going to go ahead and put angle, angle, side down here. We are wanting to prove that it is true. So the next thing they tell us, angle M, angle N, angle O equal 180. Well, if you look, angle M, N, and O are the 3 angles in that triangle. And so we know that they equal 180 by the triangle sum theorem. Same idea with P, Q, and R. P, Q, and R are the 3 angles in that triangle. So they're going to equal 180. So then the next step, if we know M, N, and O equal 180, they have M, N, and O, and we know P, QR equals 180, we can say that they equal each other because they both equal the same thing. And so that reasoning is the substitution property. Then we can go to step 5 because we already know that step 4 was given. And what changes from 4 to 5? Because it doesn't look anything like what we were just looking at in step 2 and 3. They changed the congruent symbols to equal symbols. And so that is using the definition of congruent angles. From there, 5 doesn't look like it doesn't look like 6 follows from 5. So look back. 6 doesn't follow from 5. It doesn't follow from 4. It looks more like step 3. And so let's look at what changed. M is the same. N is the same. O is the same. P is the same. But here's what changed. Q changed to N, and R changed to O. And that's what we were given in 5. So that's how we know that they changed, that they're equal. And so that is, again, using the substitution property. And then M equals P. How do we know that the measure of angle M equals the measure of angle P? Well, we can subtract the measure of angle N and the measure of angle O from both sides of our equation to produce step 7. So that's going to be using the subtraction property of equality. And then, if we know that they are equal, we can say they are congruent. So that's using the definition of congruent angles. And this is when we want to make sure, since we know that these angles are congruent, we want to add that to our figure. So I can mark angle M congruent to angle P. And so now, not using angle, side, but using angle, side, angle, side, angle, I can say that they are congruent. So that would be one way that you could prove the angle, side congruence. Now, I want to stop and discuss something that the book doesn't cover. So, CPCTC. You're going to eventually get to where you are more familiar with that ordering, but right now you'll probably get it mixed up a little bit. CPCTC. If you say it fast several times, probably a good tongue twister. So, what that represents is corresponding parts of congruent triangles are congruent. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So what that says is that if you know your triangles are congruent, then the corresponding parts are also congruent. So looking at what we just had, if we know these triangles are congruent, then we can say that angle M is congruent to angle P. Angle N is congruent to angle Q, and angle O is congruent to angle R, which we proved each of those, or we were given in our figure. We also know that the side lengths are congruent. So MN is congruent to PQ. MO is congruent to PR. And NO is congruent to QR. So that is CPCTC. If we know we have congruent triangles, all of the corresponding parts would also have to be congruent. So now let's look at the next page. They give us some pairs of triangles and they mark some angles and sides. And they want you to name what is marked and then tell whether they appear to be congruent. So yes or no, you don't have to give a paragraph or even a sentence explanation here. Just do they look like they are congruent? Just based on how they look. For these, just use S and A to tell what's marked, even if it's not a valid triangle congruence. The book is trying to get you to see a pattern and to get you to the last triangle congruence that we're going to talk about in just a minute. So if you look at the first one, what is marked is side-side angle. And they do appear to be congruent. For the second one, what is marked is again side-side angle, but they do not appear to be congruent. For C, it is again side-side angle that's marked, and yes, they appear to be congruent. And then for D, what is marked? Side-side angle. And do they appear to be congruent? Some of you may say yes. If you used patty paper and traced one and then mapped it to the other one, no, they are not congruent. So if you don't trust me, use patty paper to test that one out, but they are not congruent. Now I know this angle and that angle are not the same measure. So those two angles don't match up, so that's how I know they're not congruent. So then, number 5. We know that SSA doesn't work for all of the triangles. However, 2 of these did work. And it wants you to try and figure out, what did they have in common? Well, they are right triangles. So that's what they had in common. If they were a right triangle, it works with side-side angle. If it's not a right triangle, it's not going to work with side-side angle. And so that's going to lead us to the 5th triangle congruence that we're going to look at. And it's called hypotenuse leg. Hypotenuse leg. So it wants us to write a convincing argument, and I'm just going to kind of explain it for you to see what they're talking about. So I am going to label side angle. And then I'm going to do another triangle. Side angle. Since these are right triangles, we know using Pythagorean theorem that a squared plus b squared equals c squared. And we know over here that d squared plus e squared equals f squared. So that's just based on Pythagorean theorem. So since we know that a and d are the same length, we know a has to equal d, and we know that c has to equal f. Since a equals since a equals d, we can say a squared equals d squared. And since c equals f, we know that c squared would equal f squared. So we can replace c squared with what f squared is, which is d squared plus e squared. So I can say a squared plus b squared equals d squared plus e squared. And then I know a squared and d squared are the same thing. So a squared plus b squared, we can replace d squared with a squared. And then your a squareds would cancel out, leaving you with b squared equals e squared, which means that B equals E, because you can take the square root of both sides. So that means that the third pair of sides have to be congruent. And so I can actually say that my triangles are congruent by side, angle, side. And it just so happens that the angle that they have in common is a right angle. And this is only going to work when we have right triangles. So these triangles we could say are congruent by side, angle, side. However, I could also say they are congruent by side, side, side. Side, side, side. All three pairs of sides are congruent to each other. So if you have a right triangle, you want to see, is it congruent by hypotenuse leg? It may be, it may not be. If it's marked as side, angle, side, or side, 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 then you can use that one. However, if you end up with side, side, angle, and you don't have a right angle, then the triangles would not be congruent. So now let's look here. Is it possible to prove that the triangles are congruent using the hypotenuse leg criteria? So we know JK and LK are congruent because they give it to us. We can add that KM is congruent to KM because of the reflexive property, but we don't have any other information. We have two sides. We always have to have at least three things to be able to prove that our triangles are congruent. So these triangles are not congruent. If we were wanting to use hypotenuse leg, we would need to know that we have a right angle here, which would mean we'd have a right angle on the other side. We would need to know that these sides are perpendicular, or that one of those angles equaled 90 degrees, something along there. But you can't use hypotenuse leg unless you know you have a right triangle. For number 8, do you think there is a leg-leg congruence criterion for right triangles? So if I have a right triangle, the legs would be here. So if I said that they were congruent, it would look something like that. So a leg-leg congruence for right triangles could prove that the two triangles are congruent, but it's not necessary. And the reason is, if you look at these are congruent by side, angle, side. Side, angle, side. So we could use leg-leg congruence, but it's not necessary. It's the exact same as side, angle, side, where the given angle that they give you just happens to be a right angle. There are actually 5 different right triangle congruences, but they all, except for hypotenuse leg, revert back to the side, 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 angle, angle, or angle, angle, side. So the only one that is specific that we need to learn is hypotenuse leg. So that means that there are 5 triangle congruences. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So these are the 5 that you want to make sure that you understand and can differentiate between. So now let's go to the homework. On a coordinate plane, you want to plot the triangles and then prove that they're congruent. So if I plot the triangles, you have graph paper over here in your book. So you can actually use your graph paper. You're going to be using the distance formula to be able to prove that these are congruent. And so, if you use the distance formula, you should get that AB equals square root of 13, that BC equals square root of 5, that AC equals 2 square roots of 5. And then you should also get that DE equals square root of 13, EF equals square root of 5, and DF equals 2 square roots of 5. So if you need to pause and make sure that you understand using your distance formula to get those, you can do that. I'm not going to work through using the distance formula on those. So since these two are both square root of 13, that means that AB is congruent to DE. Since these two are both equal to square root of 5, that means that BC is congruent to EF. And then since these are both 2 square roots of 5, AC is congruent to DF. And so that is how we know that they're congruent, because the 3 pairs of sides are congruent. So the triangles are congruent by side, side, side. So that's what they were looking for on number 9. For number 10, we want to try and figure out, are any of these congruent? So our 5, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So first thing you want to do is mark anything that you can. So we know that the shared side is congruent, and so this looks like it might be side, side, angle, but that's not one of our options. Since we have a right triangle, and the hypotenuse and the leg pairs are marked as congruent, we know this is hypotenuse leg. For this next one, we can add the vertical angles as congruent, and so we end up with angle, angle, side. For number 12, we can add the shared side, but some of you may say it's angle, side, angle. But that's not right. If you look at one of your triangles, the only thing that is marked is an angle and a side. This angle goes to the other triangle. So angle, side, angle doesn't work. This is actually none of them. So you got to make sure that you're looking specifically at one triangle and not the whole figure together. On this next one, PQ bisects angle SPT. So that means that this angle here is congruent to this angle here. That does not mean that these two angles are congruent. We only know that this angle and this angle are congruent. We also know that they share side PQ, so it's congruent by the reflexive property. But again, looking only at one triangle, we have an angle and a side. And that's not enough information to prove that they are congruent. So it is, again, none. So hopefully that helps you with looking more specifically at the angle, angle, side, and hypotenuse leg congruences.